Hey guys, Mr. Riz here. So I'm going to help you guys out with the 1.3 notes. So we're going to break this section into four parts. It doesn't get too difficult at the beginning, but towards the end, this does or require us to take our time, especially when we're trying to figure out these limits analytically. So we're going to start off easy and look at kind of like direct substitution when it comes to limits. So our objectives here in this section are to make sure we can evaluate a limit using properties of limits. We're going to develop a new strategy to finding limits. We're going to make sure we can evaluate a limit using a dividing out technique. This will be the most common thing that we do here. The tough part that we get to is evaluating a limit using the rationalization technique. And then what we will kind of just gloss over is using the limit using the squeeze theorem. So let's go ahead and get this started. So let's start with the easiest thing here. And let's talk about just like if basic limits. So let B and C be real numbers, so they can be any number here, and N be a positive integer, so as long as it's positive. So like if I'm finding the limit as X goes to some number C of some number B, it's going to equal B. So in this first example here, if we have, oh, I gotta find my pen. My magic pen just disappeared on me. Where you at, boy? There you are. So in this first example, we have as X approaches 2 of 3, well, that's going to be 3. Basically, if we try to plug a 2 into this equation here, there's no X to plug it into. It's just going to be 3. Okay, next, if we hit the limit as X approaches C of X, it's going to be C. So if I take this C, plug it in for X, and it works, that's what it works out to be, that number. So this -4, as we go towards X, would be -4. All right, next here, if I have the limit as X approaches some number N, or as X approaches C, X to some number N, it's going to be C to that number power. So basically, we're just substituting here. We're taking the C and plugging it in. So if I have the limit as X goes to 2 of X squared, that'd be what, 2 squared, which is equal to 4. So when our limits get more complicated, all we need to do is just think about direct substitution, which is what this is called, works out the best way. So if we can plug it in, we plug it in. So as X goes to 2 of 4X squared plus 3, let's see, this would just be 4 times 2 squared plus 3. That'd be 4, 16, that's 19 total. So when we start off with limits, we're starting out with the most basic ones. Hence, they're called basic limits, or what's known as direct substitution. If we can take our C number and plug it into our function and it works out to be fine, it's going to be good. The problem that we will have later on is how did we do something like the limit as X goes to 3 of like X squared minus 9 over X minus 3. If I take 3 and try to plug it in here, I would get a 9 minus 9 over 3 minus 3. And we cannot divide by 0. We'll worry about that tomorrow. Today, we're going to just focus on the easy properties of limits. So notice here, direct substitution is when you can plug in the X value into the function and receive a real value. If you can't plug it in, we're going to use a graphing calculator right now to get our estimates. So the one thing about limits here is we have these rules and properties that we can apply on. So if I were just to multiply some limit, so I have some limit here, f of x is L, and I were going to go ahead and multiply that by some number b, all I need to do is take our answer for the limit and multiply that by b. Same thing works with limits with adding and subtracting. If I have a function here and I plus or minus another function, I would have to, if I'm evaluating the limits, I'll just take the limit of the one function and plus or minus the limit of the other one. Works with multiplying, and it works with dividing, and it works with 2 powers. All right, so let's go ahead, and I believe we're going to go through and just kind of stop it there. We're taking this section nice and slow. So let's look at the CYU to kind of help you guys out with some of the problems. So the biggest thing here, just to get you guys used with limits, is to have you understand, like, see if you can plug it in first. If you can plug it in, we're going to follow those rules. Alrighty, so we are on 1.3 CYU 1. Let's take a look at what's going on in this one. Okay, so if I want to find the limit as x goes to 4 g of x, I'm just going to plug 4 into the problem here. So what's 12 times the square root of 4 minus 3 over 4 minus 9? All right, so let's see, that'd be 12 times square root of 4 is 2 minus 3 over 4 minus 9 is negative 5. So what are we dealing with here? 2 minus 3 is negative 1. This would be negative 12 over negative 5. So that'd be what, a 12 over 5? If you want to put the decimal, that's fine. If you want to just type 12/5, that'll work as well. So, all right, what if we have the next one here? What about this one here? What's the square root, or 12 times the square root of 9 minus 3 over 9 minus 9? All right, so we'd get 12 times 3 minus 3 over 9 minus 9. So that is 12 times 0 over, okay, this doesn't work out. So we got to go back and do the table stuff that we did before. So if it doesn't work out, nice, we use our old technique of using Desmos and getting our table. So let's type out the equation. This should be fun. 12 times, we got the square root of x minus 3 divided by x minus 9. We're trying to find the limit as we go towards 9. So we get our table out here, and let's get close to 9, like 8.9, 8.999, 8.9999. So we're getting really close to 2. Remember, we need to double check it on the other side. 9.0001. So you can see here, if I were to go right to 9, it's undefined, but as I get closer to 9, closer to 2. So if we don't know, we have to type it into Desmos. Okay, so let's look at the rest of these here and just kind of talk about them, and you guys should be okay with this. All right, problem 2 here. Okay, can we plug negative 3 in? Yeah, just plug negative 3 and get the answer. 81. All right, can we plug 2 in? Yeah, we can. Can we plug 2 in? We sure can. All right, can we plug negative 5 in 4? You got to kind of watch out with fractions, and yeah, we can. If I plug negative 5 into this one here, I would get 5 over negative 5 plus 3. So what's that? 5 over negative 2, negative 2.2, or negative 2.5. Can I plug 3 into this one? Sure can. Okay. All right, let's look at some composite functions here. So number 7. Oh, my pen's not working. If we were going to go ahead, share the screen sharing this. Let's draw this out here. Oop, wrong marker. All right, so if I'm finding the limit as we go towards f, I'm going to take 4 and plug it into this equation here. So 2 times 4 squared minus 3 times 4 plus 1. Let's see, what's 16 times 2 will be 32 minus 12 plus 1. So that's what, 20 plus 1, 21. All right, next problem here, we got to do limit as we go to 21 of g of x. All right, so we're going to go ahead, take this number here, plug it in. So what would be 21 plus 6 to the 1/3 power? So that's 27 to the 1/3 power, aka the cube root of 27. That would be 3. And then lastly, find the limit as x approaches 4 of g of f of x. So that means we're going to take 4, plug it into f, get an answer, plug it into g. Well, this one's actually really easy because we already know if I take 4, plug it into f, I'm going to get 21. And if I plug 21 into g, we get 3. So that one's pretty easy. All righty. Just going over some more to see if they scare you. It shouldn't be too bad. Next one here, oh, we got trig function. Okay, find the limit as x approaches 2 of sine of pi times x over 2. Well, it's actually not too bad because all we're going to do is plug this in. What's the sine of pi over 2 over pi times 2 over 2? Well, really, that's just what's the sine of pi. So look at the unit circle here. Sine is the y. Where is the y value at pi? Is that 0? Same thing right over here. The limit as x approaches 5 pi over 3 cosine of x. So that's just what's the cosine of 5 pi over 3. So trig functions, I'm not going to give you anything too crazy here. Just plug it in, see what we got. So cosine is the x. What's the x of 5 pi over 3? Okay, the last one here is just making sure we can understand the property. So I have the limit as x approaches c. So we don't know what number it is, but when I go to that number of f of x, I get 27. So next couple questions here is, well, what would I get if I go to that same number of the same function, but it's to the 1/3 power? Well, I'd get 27 to the 1/3 power. Same thing here, simplify that, put the answer down. All right, same function, but we're going to the function divided by 18. So that means it's going to be 27 divided by 18. Reduce that, put that answer here. All right, same thing squared. So take 27 squared. That's probably going to be a really big number. And same thing here, 27 to the 2/3 power. So basic substitution or direct substitution, we're just plugging it in. Now, if it doesn't work out, the only technique we do know is just to use the graphing table and make a table like we did. But hopefully this helps you out. We're going to take this section nice and slow here, just to ease us up a little bit. All right, guys, have a great day. I'll see you guys next time for part 2.